We're going to begin by looking at ways you can frame to increase the effectiveness of insulation in a house. Most homes today are framed using a few basic materials, dimensional lumber, such as a 2x4, engineered products such as OSB or plywood, and insulated sheathing such as blue board or foam board. Wood has very little insulating value, and so heat passes through it easily. Heat always moves from hot to cold. That's why in improperly insulated homes, warm air leaks in during the summertime when you're cooling the house, and in the wintertime, warm inside air leaks out. So our comfort rule is that heat moves from hot to cold, and wood does much less to slow the flow of heat than insulation does. Insulation, on the other hand, does resist heat flow. That's what it's designed to do. The R on insulation refers to its resistance to heat flow. We want to frame houses in ways which maximize the use of insulation.
The framer actually can control to a certain extent whether that house is going to be comfortable or not. Everybody blames the heating and air contractor, or secondarily the insulation contractor, and obviously it gets back to the framer framing that house in a way that it's impossible to insulate properly.
There are many framing techniques we can use to make a house more insulation friendly. Corner bracing, two-stud corner framing, the use of single stud T-posts or ladder blocking at the intersections of interior and exterior walls, insulated headers, raised heel trusses, and furred out exterior stairs. Framers can significantly improve the comfort of a home simply by choosing insulated sheathing over OSB or plywood wherever possible.
Plans often call for insulated sheathing, like this blue board, but very often what we see is plywood or OSB used on the corners to provide enough lateral support for the walls. In this house, the framer used this metal corner bracing that gives the wall the lateral support that it needs, but they were able to use the insulated sheathing all around, including on the corners. This sheathing has an R value of about R3 versus plywood or OSB that has an R value of about 0.5 or R1/2. So this sheathing is about 6 times more insulating than plywood or OSB.
Corner bracing can be metal or wood. It is inexpensive and easy to install. Pop a 45-degree line and run a cut the depth of the bracing material. Hammer the brace into the stud framing, tying into the top and bottom plates. In typical framing, 3 studs come together, back to back to form a corner. Not only is this overkill, it also makes these corners impossible to insulate. One solution to this problem is to install 2 stud corners, sometimes known as California corners. There's no sacrifice of strength using this technique because corners only bear half the load of a wall stud. The corner studs come together at 90 degrees. A drywall clip or a cut piece of corner bead provides a backer for drywall. A 2x4 nailed flat can also be used as a backer. As you can see, this allows us to insulate this corner and add to the comfort of this house.
Another problem area is the T-post, where an interior wall meets an exterior wall. Typically, this is done with a 3-stud T-post, and it leaves a gap behind it where insulation can't be installed. In this house, the framer installed a 2x6 on the flat, nailed that to the end 2x4, and this did 2 things for us. One, it creates the support for the sheetrock on both sides. The other is it leaves a space behind the 2x6 so that insulation can be installed properly. Remember, whenever you have a choice to leave a space for insulation or put wood that would block it, make sure you leave the space for insulation.
Ladder blocking is another way to handle the intersection of interior and exterior walls. Lumber placed flat at intervals behind the partition stud provides a backing for drywall and yet allows for a full bat of insulation. Headers over windows and doors are also potential comfort problems. As a rule, two 2x10s are attached to a king stud, leaving a gap in between the two boards. As we know, wood is not a good insulator, and so this can create comfort problems. By placing a piece of insulated sheathing in between the 2x10s, it increases the R value of this header from R3 to R6. This is very easy to do and requires little additional material. Another problem area for insulation is roof framing. In typical construction, the roof rafters and the top plate meet in a V. When insulation is installed, it typically is compressed to fit in at the point of that V. Anytime insulation is compressed, it loses its R value.
An R19 batt of fiberglass, a 6-inch batt of fiberglass compressed into a 4-inch space is no longer R19. It's R something, but doesn't get close to be R19. And that's what we're talking about. We're talking about it's not always how much you have, it's how you have it.
In this house, the header has been raised using a 2x8 rim board. As you can see, it allows for a full batt of insulation to fit in the space without compressing it. The same principle applies to blown insulation.
Here we are in the garage, and we have a stairway on the exterior of the building. It seems almost obvious that there's very little room to be able to insulate the bottom side of this stairway. You, the framer, could make a major difference in the comfort of this house just through the framing details of this stairway. If we were actually to frame it down a bit, 4 to 6 inches, and carry that framing all the way up the bottom side of the stairway, all the way up to the top, we would actually give adequate room for the insulator to come and put in sufficient amount of insulation to make this very comfortable and reduce the energy use of the entire building.
Framers establish what is called the air barrier of the structure. That is, they determine where the exterior space stops and where the interior space begins. In order for the air barrier to work, it must be continuous. Any breaks in the air barrier allow inside air to leak out and outside air to leak in.
The greatest problem in framing is to have a leaky building, especially in a warm, moist summer. If we have a lot of outside air coming in because the building was not framed and constructed properly, then the load to the building, just by moisture, can be extremely high. On the reverse of that, in the winter, folks who live in houses that are very, very dry, that's a leaky house.
Leaks in the air barrier are likely to occur when there is a break in any of the 3 building planes: the wall, the floor, or the ceiling. If left unblocked, these breaks allow air to leak out of and into the building. So our comfort rule is whenever you have a break in the plane, a wall, ceiling, or floor, install an air barrier. Common examples of these breaks are soffits, dropped or tray ceilings, utility chases, knee walls, tub and shower stalls, and bay windows. Let's look at a few. This is a typical bay window in new construction. It provides a good example of how a break in the building plane, in this case a wall, opens up a house to air leaks.
Here's the same bay window from the inside of the house. And as you can see, we have 3 distinct open holes, somewhat like having windows open for the life of the entire building. Air can come from the outside into the entire floor system and pass from one side of the building to the other. You, the framer, need to place blocking in each one of these open cavities, creating the air barrier. Just placing insulation over these holes is not the right approach because insulation is not an air barrier.
That's right. Insulation is not an air barrier. It slows the movement of heat, but it does not stop the flow of air. Watch what happens when smoke is blown through a piece of insulation. You can see the air moves easily through it.
Often, many trades think that placing insulation between the inside and the outside creates an air barrier, but they're wrong.
As a framer, it is your job to install hard blocking between the interior and exterior space. This acts as an air barrier. Effective air barriers are dense, non-porous materials such as solid lumber, plywood, OSB, insulated sheathing, high-density cardboard such as thermoply, and even drywall can all act as an air barrier.
Here's a perfect example of the wall plane being uneven or broken. As you can see, the wall runs down, but we have a small 3-inch cantilever here. When this wall system is finished, air will still have free and easy access into the floor system. And once that air is in the floor system, it's in the house. The air that enters in there will carry with it the exhaust from the car, the chemicals that are stored in the garage. Anything that's in this garage now has free and easy access to the conditioned space.
One of the places that we see big problems is when a tub or shower is against an exterior wall. It makes it difficult for us to have our continuous air barrier and then insulate properly behind it. In this house, they used a material called thermoply, which is a very thin but solid material that the framer installed prior to the tub being installed. This gives us our air barrier all the way up behind the shower stall, and it also gives us solid backing so that insulation can be blown behind that. Now, if the house were being insulated with batt insulation, those batts would have to be installed before this air barrier material was put in. The important thing is to have some solid material as an air barrier installed before the tub gets installed. Otherwise, it's almost impossible to do it right.
Well, here we are at another one of those critical details where the framer can turn into a hero. It's where the soffit or a drop ceiling or furred down ceiling connects to the exterior of the building. Here we can see all kinds of wiring and plumbing and venting and piping. And you can even see this huge hole where the vent goes through the exterior of the building. It's just like having a horizontal framed chimney that runs across the entire portion of the building. The framer in the framing stage can easily disconnect this soffit framing from the exterior. Let me show you how. If we were to take OSB or plywood and slide it up behind the framing and then frame the soffit, drop ceiling, or furred down ceiling, then we could very easily see where this is totally disconnects this entire framing piece from the exterior of the building. In the area of comfort and knee walls, such as in bonus rooms and in cathedral rooms, the framer really has an opportunity to make a difference. That can easily be done by taking insulated sheathing and putting it on the back side of the knee wall. The second that sheathing is put in place, it creates not only a backing for insulation to be installed, but it also makes the assembly much tighter and reduces moisture flow through the same assembly as well.
As we've learned, air barriers only work if they are continuous. Any breaks allow outside air to leak in and inside air to leak out. Even the smallest gap in the air barrier can cause big comfort problems. You as a framer can seal a number of gaps with your glue and caulk guns. For example, a continuous bead of adhesive or caulk seals the gap between the second floor rim joist and the top plate of the exterior wall assembly. Another bead of adhesive or caulk should be applied to the top of the rim joist when installing the subfloor. Without those sealants, these small cracks will cause leaks in the air barrier. When a subfloor is installed over unconditioned space, such as a crawl space or a basement, it acts as an air barrier. Because the air barrier must be continuous to be effective, it's important to seal all panel joints with either adhesive or caulk. This will prevent leaks. Installing a gasket is another way you can seal the air barrier. Foam gaskets, such as Sill Seal, are readily available and inexpensive. Installing Sill Seal on the bottom plate of the exterior wall assembly will close the gap created when it is attached to the subfloor. These small details can go a long way in creating comfort. As we wrap up, let's review a few of our comfort rules. First, heat moves from hot to cold. Wood is not an insulator and therefore does little to slow the flow of heat. However, insulation does. So we want to frame homes in ways that allow us to use less wood and more insulation. We should use the following comfort framing techniques: corner bracing to increase the amount of insulated sheathing used, 2 stud corners to allow more room for insulation, single stud T-posts or ladder blocking at the intersections of exterior and partition walls, insulated headers, raised heel trusses, and furred out framing on exterior stairs. Our other comfort rules have to do with air barriers. The air barrier of a structure must be continuous to be effective. Gaps in the air barrier cause leaks. Anytime there is a break in a building plane, walls, ceilings, and floors, it's likely there will be a break in the air barrier. Framers must block those breaks. And finally, it's important to seal all gaps, including rim joist assemblies, floor panels, and sill plates. The work you do as a framer has always been important. After all, a house is only as strong as the frame holding it all together. Now you can become an even more important factor in the building process. You can build comfort for years to come.